In this lesson, you will learn about the routing capabilities and features available on FortiGate. In this lesson, you will learn about the topics shown on this slide. After completing this section, you should be able to achieve the objectives shown on this slide. By demonstrating competence in routing on FortiGate, you should be able to implement static routing and understand the routing table. When FortiGate operates in NAT mode, the default operation mode, FortiGate behaves as an IP router. An IP router is a device that forwards packets between IP networks. For that, a router performs IP routing, which is the process of determining the next hop to forward a packet to based on the packet destination IP address. FortiGate supports both IPv4 and IPv6 routing. FortiGate performs routing for both firewall traffic, also known as user traffic, and local out traffic. Firewall traffic is the traffic that travels through FortiGate. Local out traffic is the traffic generated by FortiGate, usually for management purposes. For example, when you ping a device from FortiGate, that's local out traffic. When FortiGate connects to FortiGuard to download the latest definitions, that's also local out traffic. Routers maintain a routing table. A routing table contains a series of entries, also known as routes. Each route in the routing table indicates the next hop for a particular destination. The next hop refers to the outgoing interface and gateway to use for forwarding the packet. The next hop can be the destination of the packet or another router along the path to the destination. If the next hop isn't the destination, the next router in the path routes the packet to the next hop. The routing process is repeated on each router along the path until the packet reaches its destination. To route packets, FortiGate performs a route lookup to identify the best route to the destination. The best route is the most specific route to the destination. If FortiGate finds duplicate routes, multiple routes to the same destination, it uses various route attributes as a tiebreaker to determine the best route. Routing takes place before most security features. For example, routing precedes firewall policy evaluation, content inspection, traffic shaping, and source NAT, SNAT. This means that the security actions that FortiGate performs depend on the outgoing interface determined by the routing process. This also means that your security policy configuration must follow your routing configuration and not the opposite. For each session, FortiGate performs two route lookups. For the first packet sent by the originator, for the first reply packet coming from the responder. After completing these two lookups, FortiGate writes the routing information to its session table. Subsequent packets are routed according to the session table, not the routing table. So all packets that belong to the same session follow the same path. However, there is an exception to this rule. If there is a change in the routing table that impacts the session, then FortiGate removes the route information for the session table and then performs additional route lookups to rebuild this information. FortiGate maintains its routing information in two tables, RIB and FIB. The routing table, also known as the Routing Information Base, RIB, is a standard routing table containing active, or the best, connected, static, and dynamic routes. The Forwarding Information Base, FIB, can be described as the routing table from the kernel point of view and contains mostly RIB entries plus some system-specific entries required by FortiOS. When FortiGate performs a route lookup, it checks the FIB and not the RIB. However, because the FIB is composed mostly of RIB entries, a route lookup mainly involves checking routes from the RIB. For this reason, the route lookup is often referred to as the routing table lookup process. Nonetheless, it is more accurate to refer to a route lookup as a FIB lookup process. You can only display the RIB entries on the FortiGate GUI and CLI. You can display FIB entries on the FortiGate CLI only. This lesson focuses on the RIB, or routing table, only. You will learn more about it, including how to monitor its entries, in this lesson. The flowchart on this slide describes the route lookup process in FortiOS. First, FortiGate checks the policy routes. If there is a match and the selected action is forward traffic, FortiGate routes the packet accordingly, as long as the policy route passes the Forwarding Information Base (FIB) validation process. If the selected action is Stop Policy Routing, FortiGate moves on to check its route cache if applicable. If the packet doesn't match any of the policy routes, FortiGate moves on to check the ISDB routes first, and then the SD-WAN rules. Next, FortiGate checks the FIB, which is the table that it used to perform standard routing. If the packet doesn't match any of the routes in the FIB, FortiGate drops the packet and sends an ICMP destination network unreachable message to the sender. One type of manually configured route is called a static route. When you configure a static route, you are telling FortiGate, when you see a packet whose destination is within a specific range, send it through a specific network interface towards a specific router. You can also configure the distance and priority so that FortiGate can identify the best route to any destination matching multiple routes. You will learn about distance and priority in this lesson. For example, in simple home networks, DHCP automatically retrieves and configures a route. Your modem then sends all outgoing traffic through your ISP internet router, which can relay packets to their destination. This is typically referred to as a default route because all traffic not matching any other routes will, by default, be routed using this route. The example shown on this slide is a default route. The destination subnet value of 0.0.0.0/0.0.0.0 matches all addresses within any subnet. Most FortiGate devices deployed at the edge of the network have at least one of these default routes to ensure internet traffic is forwarded to the ISP network. Static routes are not needed for subnets to which FortiGate has direct Layer 2 connectivity. If you create a firewall address object with the type subnet or FQDN, you can use that firewall address as a destination of one or more static routes. First, enable routing configuration in the firewall address configuration. After you enable it, the firewall address object becomes available for use in the destination drop-down list for static routes with named addresses. What happens if you need to route traffic to a public internet service, such as Amazon AWS or Apple Store, through a specific WAN link? Say you have two ISPs and you want to route Netflix traffic through one ISP and all your other internet traffic through the other ISP. To achieve this goal, you need to know the Netflix IP addresses and configure the static route. After that, you must frequently check that none of the IP addresses have changed. The Internet Service Database, ISDB, helps make this type of routing easier and simple. ISDB entries are applied to static routes to selectively route traffic through specific WAN interfaces. Even though they're configured as static routes, ISDB routes are actually policy routes and take precedence over any other routes in the routing table. As such, ISDB routes are added to the policy routing table. The Routing Monitor widget on the dashboard page enables you to view the routing table and policy route table entries. The routing table contains the best routes, or active routes, of the following types. Static, manual routes that are configured by the administrator. Connected, automatic routes added by FortiOS after an interface is assigned an IP address. A connected route references the interface IP address subnet. Dynamic, routes learned using a dynamic routing protocol, such as BGP or OSPF. FortiGate installs these routes automatically in the routing table and indicates the dynamic routing protocol used. To view the routing table entries, select Static and Dynamic, as shown on this slide. However, keep in mind that the routing table doesn't contain the following routes. Inactive routes. These are the static and connected routes with interfaces that are administratively down or with links that are down. Static routes are marked inactive when the link health monitor detects that their gateway is dead. Standby routes. These are active routes that are removed from the routing table because they are duplicate and have higher distances. Some examples of standby routes are a second static default route with a higher distance than another static default route, a dynamic route such as BGP or OSPF to the same destination as another static route. However, the dynamic route is not displayed in the routing table because the static route has a lower distance. Policy routes. These include regular policy routes, ISDB routes, and SD-WAN rules. Policy routes are viewed in a separate table, the policy route table. You will learn more about policy routes in another lesson. Each of the routes listed in the routing table includes several attributes with associated values. The network column lists the destination IP address and subnet mask to match. The interfaces column lists the interface to use to deliver the packet. The distance, metric, and priority attributes are used by FortiGate to make various route selection decisions. You will learn about each of these in the lesson. This slide also shows the command you can run to display the routing table on the FortiGate CLI. The Get Router Info Routing Table All command displays the same route entries as the Routing Monitor widget on the FortiGate GUI. Distance, or administrative distance, is the first tiebreaker that routers use to determine the best route for a particular destination. If there are two or more routes to the same destination, duplicate routes, the lowest distance route is considered the best route and, as a result, is installed in the routing table. Other lower distance routes to the same destination are standby routes and, as a result, are not installed in the routing table. Instead, they are installed in the routing table database. You can set the distance for all route types except connected and ISIS routes. Both are hard-coded, and their distance value cannot change. This slide shows the default values per type of route. In case FortiGate learns two equal distance routes to the same destination, but that are sourced from different protocols, then FortiGate installs in the routing table the route that was learned last. For example, if you set the distance of BGP routes to 110, and there is another OSPF route to the same destination using the default administrative distance, 110, then FortiGate keeps whichever route was learned last in the routing table. Because this behavior can lead to different results based on the timing of events, then it's not recommended to configure different protocol routes with the same distance. When a dynamic route protocol learns two or more routes to the same destination, it uses the metric as a tiebreaker to identify the best route. The lower the metric, the higher the preference. The dynamic routing protocol then installs the best route in the routing table and the higher metric routes in the routing table database. Note that the metric is used as tiebreaker for same protocol dynamic routes and not between different protocol dynamic routes. The metric calculation differs among routing protocols, and the details are not covered in this course. For example, RIP uses the hop count, which is the number of routers the packet must pass through to reach the destination. OSPF uses cost, which is determined by the link bandwidth. When there are two or more duplicate static routes that have the same distance, FortiGate installs all of them in the routing table. The priority setting enables administrators to break the tie among static routes. During the route lookup process, FortiGate selects the best route, that is, the static route with the lowest priority among all the equal distance, duplicate static routes. The lower the priority value, the higher the preference. The priority attribute applies to all routes except connected routes and is set to 1 by default. For dynamic routes, you can change the priority of BGP routes only. The priority of other dynamic routes is hard-coded to 1. In dynamic routes, the priority value is useful for advancing routing deployments involving SD-WAN and multiple virtual routing and forwarding (VRF) IDs. A detailed explanation of how the priority attribute is beneficial for such cases is outside the scope of this course. For static routes, you can configure the priority settings in the Advanced Options section, as shown on this slide. To view the priority in the Routing Monitor widget, you must enable the priority column, disabled by default. You can also view the priority in the routing table on the FortiGate CLI. The CLI command shown on this slide displays all entries in the routing table. The routing table displays the routes that make it the best active routes to a destination. The leftmost column indicates the route source. Route attributes are shown inside square brackets. The first number in the first pair of attributes is distance, which applies to both dynamic and static routes. The second number is metric, which applies to dynamic routes only. Static routes and dynamic routes also have priority and weight attributes, which are shown as the last pair of attributes for the respective route. In the case of dynamic routes, the weight is always 0. This command doesn't show standby or inactive routes, which are present in the routing table database only. For example, when two static routes to the same destination subnet have different distances, the one with the lower distance is installed in the routing table, and the one with the higher distance in the routing table database. You can perform a route lookup on the Routing Monitor widget by clicking Route Lookup. Then, you must indicate at least the destination address to look up for, and optionally, the destination port, source address, source port, protocol, and source interface. The way the route lookup works is as follows. If you don't provide all lookup criteria, FortiGate considers only the routing table entries. FortiGate then highlights the matching route, if any. If you provide all lookup criteria, FortiGate considers both routing table and policy table entries. If the lookup matches a policy route, the GUI redirects you to the policy route page and then highlights the corresponding matching policy route. The example on this slide shows a route lookup tool for 8.8.8.8 and TCP as destination address and protocol, respectively. Because the administrator doesn't provide all criteria, FortiGate considers the routing table entries only. Then, the route lookup highlights the static default route as the matching route. The RPF check is a mechanism that protects FortiGate and your network from IP spoofing attacks by checking for a return path to the source in the routing table. The premise behind the RPF check is that if FortiGate receives a packet on an interface, and FortiGate doesn't have a route to the packet source address through the incoming interface, then the source address of the packet could have been forged, or the packet was routed incorrectly. In either case, you want to drop that unexpected packet, so it doesn't enter your network. FortiGate performs an RPF check only on the first packet of a new session. That is, after the first packet passes the RPF check and FortiGate accepts the session. FortiGate doesn't perform any additional RPF checks on that session. There are two RPF check modes. Feasible path, formerly known as loose, it's the default mode. In this mode, FortiGate verifies that the routing table contains a route that matches the source address of the packet and the incoming interface. The matching route doesn't have to be the best route in the routing table for that source address. It just has to match the source address and the incoming interface of the packet. Strict. In this mode, FortiGate also verifies that the matching route is the best route in the routing table. That is, if the routing table contains a matching route for the source address and incoming interface, but there is a better route for the source address through another interface, then the RPF check fails. This slide also shows how to change the RPF check mode on the FortiGate CLI, as well as how to disable the RPF check on the interface level. Good job! You now understand routing on FortiGate. Now, you will learn about Equal Cost Multipath, ECMP routing. After completing this lesson, you should be able to achieve the objective shown on this slide. By demonstrating competence in ECMP routing, you will be able to implement routing load balancing. So far, you've learned about the different route attributes that FortiGate looks at to identify the best route to a destination. But what happens when two or more routes of the same type have the same destination, distance, metric, and priority? These routes are called Equal Cost Multipath, ECMP routes, and FortiGate installs all of them in the routing table. FortiGate also load balances the traffic among the ECMP routes. The example on this slide shows 2 ECMP static routes, 2 ECMP BGP routes, and 2 ECMP OSPF routes. For each ECMP group, the destination subnet, distance, metric, and priority are the same. The result is that FortiGate installs both routes of each ECMP group in the routing table. This lesson, however, focuses on ECMP static routes only. ECMP can load balance sessions using one of the following 4 algorithms. Source IP. This is the default algorithm. FortiGate uses the same ECMP route-to-route sessions sourced from the same address. Source destination IP. FortiGate uses the same ECMP route-to-route sessions with the same source destination IP address pair. Weighted applies to static routes only. FortiGate load balances sessions based on the route weight or the respective interface weight. The higher the weight, the more sessions FortiGate routes through the selected route. Usage, spillover. FortiGate sends sessions to the interface of the first ECMP route until the bandwidth of the interface reaches the configured spillover limit. After the spillover limit is reached, FortiGate uses the interface of the next ECMP route.
If SD-WAN is disabled, you can change the ECMP load balancing algorithm on the FortiGate CLI using the commands shown on this slide. When SD-WAN is enabled, FortiOS hides the v4 ECMP mode setting and replaces it with the load balance mode setting under Config System SD-WAN. That is, when you enable SD-WAN, you control the ECMP algorithm with the load balance mode setting. For spillover to work, you must also configure the egress and ingress spillover thresholds, as shown on this slide. If you disable SD-WAN, FortiGate selects the lowest numbered interface first. The thresholds are set to 0 by default, which disables spillover check. For a weighted algorithm, you must configure the weights at the interface level or route level, as shown on this slide. If 2 or more routes are added to the routing table, and you set v4 ECMP mode to weight-based, FortiGate routes sessions based on the weight value of each route.
In the scenario shown on this slide, FortiGate has ECMP routes for the 10.0.4.0/24 subnet on port 1 and port 2. Using the default DCMP algorithm, source IP-based, FortiGate may use any of the 2 routes to route traffic from user A and user B. In the example shown on this slide, FortiGate selects the route over port 1 for user A and the route over port 2 for user B. FortiGate continues to use the same selected routes for the same traffic. If the route over port 1 is removed from the routing table, FortiGate automatically starts to forward the traffic sourced from both users and destined to 10.0.4.0/24 through port 2. ECMP enables you to use multiple paths for the same destination, as well as provide built-in failover. Usually, you want to use ECMP for mission-critical services that require high availability. Another reason to use ECMP is for bandwidth aggregation. That is, you can leverage the bandwidth of multiple links by load balancing sessions across them. While ECMP enables you to leverage multiple WAN links on FortiGate, you may want to use SD-WAN because of the additional benefits.
Gerencie sua equipe e distribua as tarefas como quiser com o Hanhanity.
When you
Quer
enable
ver as
SD-WAN,
etapas, use
FortiOS
Você
hides the
CLT
v4
como
ECMP
suporte
mode
em
setting
situações
and
é uma
replaces it with
fechar
the
o
load
extrato
balance mode
necessário
setting
seu
under Config
completo e
System
clique
SD-WAN.
no seu e-mail.
That is, after you enable
Pronto,
SD-WAN,
agora
you
você
now
poderá
control the
consultar o
ECMP algorithm
seu
with the
saldo
load
e analisar
balance
se o seu
mode
empregador
setting.
está
There are
pode
some
sacar os
differences
valores
between the two
depois
settings.
está trabalhando.
The
Essas
main difference
situações
is that
através de
load
uma
balance
FGTS
mode
sem a
supports the volume
antecipação ser
algorithm,
retirada.
and
Como faço para
v4
sacar o meu
ECMP
FGTS?
mode does not.
O saque do
In
FGTS
addition, the related settings, such as weight and spillover thresholds, are configured differently. That is, when you enable SD-WAN, the weight and spillover thresholds are defined on the SD-WAN member configuration. When you disable SD-WAN, the weight and spillover thresholds are defined on the static route and interface settings, respectively. When you set the ECMP algorithm to volume, this is when SD-WAN is enabled. FortiGate load balances sessions across members based on the measured interface volume and the member weight. That is, the volume algorithm instructs FortiGate to track the cumulative number of bytes of each member and to distribute sessions based on the weight. The higher the weight, the higher the target volume of the interface, and as a result, the more traffic FortiGate sends to it. Congratulations, you have completed this lesson. Now, you will review the objectives covered in this lesson. This slide shows the objectives that you covered in this lesson. By mastering the objectives covered in this lesson, you learned how to configure, monitor, and load balance routes on FortiGate.